students. So in the sequences and series, we have seen what is geometric progression. Okay, we have seen the formulas also. Today we are going to see what is geometric mean. Okay, so geometric mean, that is given by GM, is the mean of two positive numbers a and b. Okay, root a. This is given by root a. Now, say in general, G1, G2 till Gn be the n numbers between positive numbers a and b. Okay, in a GP, then b is given by a r raised to n plus 1 or r is given by b by a raised to 1 upon n plus 1. Okay, so our first term, that is G1, is given by AR. That is A into this R you have to substitute. B upon A, 1 upon n plus 1, and so on. So our Gn will be what? AR is to n. So AR is to n is B by A, 1 upon n plus 1. So here n will come. Okay, let's see some examples. So the example is given in the textbook. Insert three numbers between 1 and 256. So this is 1 and 256. We have to insert three numbers, G1, G2 and G3. Okay, this is our A, this is our B. So we can find R. Okay, R is given by B by A, 1 upon n plus 1. So B is 256 upon 1 upon n. Total n is our, these three numbers are there, so 3 plus 1, so 4. Correct? So 256 raised to 1 by 4. This is R. So R raised to 4 is 256. Okay? If you divide by 2, that is, if you take root of this will be 256. 16 square. Yeah. So this becomes 16. This will be R square. So R is plus or minus 4. Okay. So we got R. So we can find G1. G1 is given by A into R. A is 1 into 4. So it will be 4. For minus 4, G1 will be minus 4. Okay. Same way you can find G2 and G3. So 4, 16 and 64. Then there is a relationship between AM and GM, that is arithmetic mean and geometric mean. Okay, so A is given by A plus B by 2 and geometric mean is given by root of AB. So the relation is given by A is greater than or equal to G. Okay, Now we'll see one example, that is if am and gm of two positive integers a and b are 10 and 18. So arithmetic mean is given and geometric mean is given. 10 and 8. You have to find the numbers, that is a and b you have to find. This is our a plus b by 2 and this is root of ab. Okay. So from this we can write this as 20 is equal to a plus b. And from this is squaring both the sides, you will get 64 is equal to ab. So a we can substitute as 64 upon b, okay, in first equation. So 64 upon b plus b equal to 20. So b square minus 20b plus 64 equal to 0. Yeah. So you can solve this equation. Sixteen four, yeah. So this is b minus 16 and b minus 4. So b is equal to 16 or b is equal to 4. Okay. So putting this equations here or in this, you will get for b equal to 16, you will get a equal to 4. And for b equal to 4, you will get a equal to 16. Okay. So these are the values of a and b. Let's solve exercise 9.3. Okay. First question, you have to find the 20th and nth term of the GP. GP is given 5 by 2, 5 by 4, 5 by 8 and so on. So our first term is 5 by 2 and the ratio is 5 by 4 divided by 5 by 2. So this is 5 by 4 into 2 by 5. So it is half. Okay, A is there, R is there. So A20 is A, R is to 20 minus 1. So A is 5 by 2. R is half raised to 90. Okay. So if you want, you can solve this or you can keep it as it is. An is A, R is to n minus 1. So 5 by 2 half is to n minus 1. Okay. Second question. Find 12th term of the GP whose 8th term is 192. So 8th term is given and common ratio is given. Okay. A8 is given. A8 is given by A R is to 8 minus 1. That is 7. So this is 192. R is also there. So we can substitute 192 on 2 raised to 7. So I can you can find factors, that is prime factors. Okay. 1, 2, 3, 4, 5, 6. So this is 2 raised to 6 into 3 and this is 2 raised to 7. So 1, 2 remains. So this is 3 by 2. Okay, this is A. We have to find 12th term. Okay, A12. A r is 2, 12 minus 1. A is 3 by 2. R is 2 raised to 11. Okay. So this 2 you can take here. So it will be 11 minus 1. 10. Okay. Next question here, 5th, 8th and 11th term is given. You have to show that q square is equal to ps. Okay. So a5 can be written as a r is to 4, a r is to 7 and a r is to 10. Okay. So if I divide r is to 7 by r is to 4, then r is to 10 by r is to 7, we'll get some equations. Okay. So I'll divide. This is 1, 2, 3. So dividing 2 by 1, we get q upon p. So r is to 3 equal to q upon p. Okay. Then 3 by 2. Both are same. So we can equate them. Qs. This is s upon q. So this is what we required. Okay. Fourth question. Fourth term of a GP is square of its second term. So fourth term of a GP is square of its second term. Okay. And the first term is minus 3. You have to determine its seventh term. Okay. So we can write this as a r is to 3. A square is a r square. Mm, 1 gets cancelled, 1 gets cancelled. So r equal to a. A is given minus 3. So r is minus 3. Okay. A7 is a r is to 6. Is minus 3. This is minus 3 raised to 6. This is 1. So 6 plus 1, 7. Okay. Next question, which term of the following sequence? So sequence is given. Which term is 120? It means we have to find n. Okay. Is there r is 2 root 2 upon 2. So root 2. An is our 128. A r is to n minus 1. A is 2. R is root 2 minus 1. So 128 divided by 2 is to n minus 1. 64. So this we have to equate. That is root 2 we can write as 2 raised to half. So this will be n minus 1 upon 2. 64 we can write it as 2 raised to 64 is 8 square, which is 2 is 8. This is 2 into 2, 2 cube. 8. This is 64, right? So you can find the prime factors of 64. So you'll get this is 2 raised to 5, this is 2 raised to 6. 2 raised to 6 equal to 2 raised to n minus 1 by 2. Okay, so we can equate the power. N is 30. Okay. Next question. Sequences given. So we have to find 729. Okay. So AN 729 is root 3. R is 3 upon root 3. Now 729. Again you have to find the factors. And we'll get that this is 3 raised to 6. This we can write as 3 by root 3. If I multiply by root 3, this will be 3 root 3 upon 3. Correct? So this is root 3. So n minus 1 plus 1. So this is 3 raised to n by 2, 3 raised to 6. So now this will be n by 2 equal to 6. N is 12. Okay. Next sequence is 1 by 3, 1 by 9, 1 by 27. So we have to find 19683. A is there, R is also there. So R is 1 by 9 upon 1 by 3. So we have to find this in terms of 3. So you can find the prime factors and we'll get it as 3 raised to 9. So this is raised to 9. So n is 9. Okay.